Okay, let's take a look at our application problems for section 8.1. Keep in mind that we're looking at right triangles. So we are assuming every triangle in here is a right angle, or right triangle. Okay, on this first one, we've got this hotel. We know the elevation here is 3,100 feet. This is angle B. We know the length of the trail is 14,100 feet. It asks us to find the angle B, so this angle measurement. And since we're given the opposite side and the hypotenuse, that means I'm going to be dealing with sine. So the sine of B, capital B, because it's an angle, is equal to the opposite, so 3,100 divided by the hypotenuse, so 14,100. Again, if I'm trying to find the angle B, I'm going to have to do the inverse of sine. So in the calculator, I'm going to have to say B equals sine inverse of 3,100 divided by 14,000. So B equals, or the angle B equals, let's go over the calculator real quick. Make sure when you turn your calculator on, you go to mode and change this to degrees, or you will not have the correct answers. So first thing, we change it to degrees and quit. Now we need to do sine inverse, that's second sine 3,100 divided by 14,100. Make sure that is inside the parentheses, or again, you will not get the correct answer. Enter. And our angle, we're going to keep 2 degrees here, so 12.71 degrees. That's all there is to this. Okay, I've got a second problem here, a surveyor, and he's setting up a camp here, a transit area, and wants to go across the river. But he's trying to figure out how far is that river. So we are trying to find B. So a side. I know this length is A, and I know this measurement here. So I've got an opposite side and adjacent side that we're dealing with. So the trig function that deals with both of those is tangent. So tangent of, again, we have to look at the angle we're given, so tangent of 20 degrees is equal to the opposite side, so that's B, divided by our adjacent side, which is 200. So if I'm trying to find B, I would multiply both sides by 200, which gives me 200 times the tangent of 20 degrees, and that's going to be B. So when I plug this in the calculator, 200 tangent of 20, and we get 72.79. And the units would be the same units. So we were in meters, this would be in meters. There we go. Let's move on to the second side. On this side, we're talking about the angles of elevation and depression. The angle of elevation is compared to where you are, what that angle is going upwards. So if you're looking up at something in the sky, at a mountain, the water tower, any of those would be an angle of elevation. Angle of depression is when you're looking downwards. So if you're up on a cliff and looking downwards, this angle right here is your angle of depression. Okay, so here we are. We've got a light detector over here. This is my theta. We know this is a 90-degree angle. And so they're telling us this base B is 300 feet. So I've got that. I'm also told that this angle here is 75 degrees. So I've got 75 degrees that's over here. And I want to find the height. How far up are those clouds? So if I'm trying to find H, I know relative to angles of 75 degrees, I know the adjacent side. I'm trying to find the opposite. So that sounds like a tangent function I should use. So the tangent of 75 degrees is equal to H divided by 300. If I'm trying to find H, I need this 300 over here. So multiply both sides by 300, which gives me 300 times the tangent of 75 degrees equals H. We're going to plug this in the calculator now. Okay, so we've got 300 tangent of 75 degrees, 1,119.62. We need to round that up. and that would be in feet. So the clouds are 1,119.62 feet above ground. Okay, got one last example over here. So here we're comparing two different buildings, which tells me I'm looking at different heights here. So the height of one to the height of the second. Okay, so the second one is the statue. So what we're comparing is from where we're standing to the base of the building. So that's 400 feet, so that's the same. The angle when I am looking up is 55 degrees, 0.1. So that's the top of the building. If I look up a little bit higher, I can see the top of the statue, which gives me a 56.5 degree angle. Okay, so let's see what we're trying to find, these two different heights. So let's look at this first triangle. Again, I'm looking relative to this angle, I'm dealing with an opposite and an adjacent side. So that's going to be tangent. So tangent of 55.1 degrees is equal to b divided by 400. So if I'm trying to find b, multiply both sides by 400. I've got 400 times the tangent of 55.1 is equal to b. So let's plug this in the calculator now. And we've got 400 times the tangent of 55.1 degrees is 573.39. Okay. Okay, so we've got the height now of the building. So this is our building. Now we're going to look at the height from the ground to the top of the statue. So that's what this second triangle represents. And again, we're going to be dealing with tangent. So I've got tangent of 56.5 degrees is equal to b prime. Again, we're just using that to designate it's a different height here. Also divided by 400. Multiply both sides by 400. So 400 times the tangent of 56.5 degrees is equal to b prime. Just one little mark there. So b prime is equal to, let's see what we get here. 400 times tangent of 56.5. We get 604.33. Okay, so this is the height all the way to the top of the statue. This is the height to the top of the building. I want to know the height of the statue. So the statue height, I have to take my height to the top of the statue, which is 604.33, subtract the height of the building. So the height of the building was 573.39. When I subtract these, I will get the height of the statue. So 604.33 minus 573.39. I get the statue is 30.94 feet. Okay? So again, just look at what you know and try and decide what trigonometry function would work best.